There is a quiet shift happening in how humans imagine building things, and it starts with a simple question. What if instead of forcing the world to fit our limits, we learn to build with the conditions we are given? For most of human history, construction meant weight, gravity, friction, hands, sweat, and time. Even when we dreamed about space, we still carried those same assumptions with us. We imagined astronauts floating slowly, tightening bolts, moving carefully, trying not to make mistakes. We imagined building in space as an extension of building on Earth, only harder and more dangerous. But there is another way to think about it. What if space is not a problem to overcome, but an environment to collaborate with? What if the absence of gravity is not a weakness, but a feature? That is the context for this idea of structures that grow themselves in orbit, modular pieces that arrive and connect, magnets clicking into place, no human hands required. At the surface, the idea sounds like efficiency. Faster building. Less risk. Bigger structures. But the deeper meaning sits somewhere else. Insight 1 is the surface concept, that building does not always need builders in the traditional sense. When we hear the word construction, we picture workers, tools, schedules, and oversight. We picture effort being applied directly to material. But nature does not work that way. Crystals form without hands. Snowflakes assemble without instructions being shouted. Cells organize themselves based on simple local rules. What this system does is borrow that logic. Each tile does not need to know the whole plan. It only needs to know how to connect to its neighbor. Click. 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 Over time, structure emerges. This is a powerful shift. It suggests that intelligence does not need to sit at the center. Intelligence can be distributed. Instead of one astronaut doing a risky task, the system itself handles alignment, docking, correction. In everyday life, we already trust systems like this more than we realize. Traffic flows not because one person directs every car, but because each driver follows simple rules. The internet works not because one server knows everything, but because packets find their way. When building becomes distributed, scale stops being terrifying. You can build bigger than your biggest rocket because no single launch needs to carry the whole idea. You send pieces. You let them meet. You let them assemble. Insight 2 is the hidden assumption that space has value only when humans are physically present. For decades, our stories about space have been centered on people. Astronauts planting flags. Humans walking on new worlds. Human bodies adapting to harsh environments. That story is inspiring, but it also narrows our imagination. It makes us think that progress in space must wait for safer suits, stronger bones, longer endurance. But the hidden assumption here is challenged. Space can work for us even when we are not there. Microgravity changes how matter behaves. Proteins grow differently. Tissues organize in new ways. Chemical processes unfold without settling or sinking. These are not small curiosities. They are opportunities. Think about medicine. On Earth, gravity quietly interferes with precision. In space, structures can form more cleanly. Imagine therapies that are impossible to stabilize on Earth but become viable when made in orbit. Imagine drugs discovered not by pushing harder in labs, but by letting physics do something new. The assumption that space is only about exploration gives way to a different idea. Space is a factory. Space is a laboratory. Space is a place where Earth's hardest problems can be addressed indirectly. Not by escaping Earth, but by supporting it from above. Insight 3 is the structural pattern, that the future favors systems that can reconfigure instead of systems that are fixed. Traditional infrastructure is rigid. Once you build a bridge, it is a bridge. Once you build a station, it has one purpose. Changing it later is expensive and slow. In space, that rigidity becomes dangerous. Needs change. Missions evolve. New discoveries demand new layouts. A modular self-assembling system does something different. It allows change without destruction. If you need more capacity, you add tiles. If you need a different function, you rearrange. If something fails, you replace a part instead of the whole. We already see this pattern in software. Programs update. Features change. Bugs are patched. Hardware is now learning from that logic. Instead of building monuments, we build organisms. Structures that can grow, adapt, and heal. This is not just about space. It reflects a deeper pattern in how humans are learning to design. We are moving away from final answers and toward ongoing processes. Away from finished products and toward evolving systems. Now comes the reframing. This is not a story about escaping Earth or racing toward Mars. It is a story about humility. About recognizing that Earth-based thinking has limits. For a long time, we tried to solve every problem by doing more of what already worked. Bigger machines. Stronger materials. More effort. Space asks a different question. What if doing less is better? What if letting go of control creates new possibilities? When you allow structures to assemble themselves, you admit that you do not need to oversee every detail. You trust physics. You trust design. You trust emergence. That mindset is valuable far beyond orbit. We live in a world that often rewards tight control and constant supervision. But many of our biggest challenges are too complex for that approach. Climate systems. Supply chains. Health networks. These systems behave more like space structures than machines. They respond better to simple rules, modular design, and adaptability. Application to daily life can feel distant when the topic is orbiting habitats, but the lesson translates. Think about how you build your own projects. Do you try to plan everything in advance? Do you wait until you have the perfect conditions? Or do you create small pieces that can connect and grow over time? A career can be modular. Skills as tiles. Relationships as connectors. You do not need the whole structure before you begin. You send parts. You let them meet opportunities. You allow assembly to happen gradually. In teams, this idea matters even more. Instead of assigning one person to hold all responsibility, you design roles that snap together. Each person knows how to connect, how to support, how to adjust. The result is stronger than any single effort. Even in learning, we can think this way. You do not master a subject in one launch. You build understanding piece by piece. Some parts connect immediately. Others float until the right moment. Over time, a structure forms. Optional deepening is to reflect on what it means to put space to work for Earth. There is a quiet ethical statement in that idea. It suggests that progress is not about leaving problems behind. It is about finding new angles to address them. Space becomes not an escape, but a mirror. It shows us what happens when we design with respect for environment, constraints, and long timelines. A modular habitat that assembles itself is patient. It does not rush. It does not demand heroics. It values reliability over drama. In a world addicted to speed and spectacle, that is a radical posture. And when we talk about trillion-dollar economies and distant planets, it is easy to miss the quieter promise. That the same thinking could lead to safer work, better medicine, and systems that fail less catastrophically. That the future might be built not by grand gestures, but by many small pieces clicking into place, calmly, reliably, again and again. So as we look toward a future where structures grow and orbit and space becomes a partner rather than a frontier, what parts of your own life or work could become lighter and more adaptable if you stopped trying to build everything by hand and allowed simple pieces to assemble over time?